we have one presentation for you today with one presenter. Bob Mahoney's engineering course is really cutting into my... But we looked at the Headworks building, so we have a 2P on the Headworks building. I'll let Zach explain all of that to you, and I'll turn it over to him.
Good morning, everyone. So this is part of the North Water Treatment Plant project. So for those of you who are not familiar with the project, we are building a new plant up at Ralston. So we've done a 2P event. Right now we're at 30% design. So we're going back and looking at the layouts. We're looking at our design and seeing if there are any efficiencies, any improvements that we can still generate and create out of an already excellent design. So we've done a 2P event on the filtration building, and we created a lot of improvements there, a lot of efficiencies. We've also done a 2P on the flocculation sedimentation process. Again, great results. We've done a CBA on keeping Moffett and what we would keep, what we would decommission, and so on and so forth. So this is the last, at least, 2P event for the NTP processes, and this is for the Headworks building. So this is where the conduit comes in, or the raw water comes in. In the NTP case, we will have hydropower generation, so I'll mention also the hydro layout. We had a really amazing team. We've really had great teams for all the 2P events, but just to go through the names from left to right, Troy was simpler. He's our lean facilitator. Brandon from the Foothills facility, and his participation, him and Jimmy, was really valuable because they operate a hydro facility out at Foothills. Next to Brandon is Erin Jacobs. She's with AECOM, one of our consultants on the project. Joel from Water Distribution. Again, they operate several hydro plants within the distribution system. Maddie, she's with construction, Denver Water Construction. She's a newcomer. I think she's been on the job for 6 months or so, and it was her first lean event. So Tom with CDM Smith, another consultant. Tad Kogan, our asset manager. Jenny Miller with Corolla Engineers. They're mainly focused on the instrumentation controls for the NTP project. And let's see, Brian Thomas, another consultant. David Blood, he's another consultant. Jamie at the Foothills facility. Boyd with Kiewit Construction. Nathan, our Denver Water Engineering. Jeff, CH2M, Hill, Jacobs now. Casey, our electrical engineer here at Denver Water. Adam, and last one on the right is myself. So we spent a couple of days looking at and before I forget, again, just want to thank everybody from the treatment folks. They really provided great input on the project, what they would like to see maybe for changes or improvements, what they like already on the design. So their voices were captured and incorporated in what we did with the 2P. Ian Oliver, our SOS director, and really all the Denver Water trade shops, their contributions are always valuable and helpful. And if I've missed anybody, I'm sure there's a lot of people that Austin and the CI team, they always do a phenomenal job. So again, the reason we're doing this is we're at the 30% milestone, and this is a really good place to stop and look at the design we have. Take into account all the voices, the folks that are going to operate and maintain the facility. It's kind of more kind of a checklist, if you will, just to see if what we have today still meets our needs and the ratepayers' needs before we move to the next milestone, which would be the 60%. So the first step in the process, we went over the voice of the customer, which is really, for the most part, the treatment plant folks and trade shops. And again, this is all the feedback we got from them. We looked at things, basic needs, things like the lighters, things that would be nice to have. Looked at, the wishes and the needs, and try to incorporate as much of that in our evaluation of the 30%. And then we, addressed the SIPOCs. We looked at operations walkthrough. So we actually used a 3D model and walk through the process just to see kind of what the touch points would be, how accessible the site would be in case of an emergency. Would it be easy to deal with emergencies? Maintenance, how would the maintenance take place, whether it's repairs or replacements, in the near or far future. Hydro maintenance was kind of the key point. We're going to have 2 hydro power generators in the facility, and that requires some maintenance on regular basis, probably some major maintenance at some point down the road. So we're very mindful of how that's going to happen and take place and how we would stage for it. And that would be more the hydro breakdown every so many years. So the current state, the 30% design right now, we have the base level, the grade. Basically, you have 2 generators, a large one and a smaller one, and then 2 sleeve valves. And the idea is when the sleeve valves, their purpose is to reduce the pressure coming from Ralston Reservoir as it enters the plant and then control the flow. But for the most part, we would be running on either the small generator or the large generator, depending on the flow rate coming into the plant. And that just to generate power to supply the plant itself. So it'll be, for the most part, basically dependent on its own power. The sleeve valves will play into it when we start the plant up on low flows. As we get up on flow rates, at some point, we would have the large generator in addition to possibly one of the sleeve valves in operation as well. On top, and that's what it says current state, that's north, this is south. On top, we would have a mezzanine that would house the electrical room, control room, a battery room, and then CO2, carbon dioxide feeders. We need that chemical seasonally to inject in our water, and also a restroom as well. So we split up into 2 teams, and we balanced it for the most part, where every team had people from operation and maintenance, from the trade shops, consultants, and we really challenged ourselves to come up with 7 different ways, each team, on how we would do this different or improve it or change it. That wasn't easy. I mean, it was already a good design to begin with. It's a small facility. As you can see, there's a lot of pipes and a lot of equipment in the way. So trying to basically reinvent it wasn't the easiest thing. But nonetheless, we still came up, I think, for at least with 6 options each team. So we looked at those layouts and designs, and then boiled that down, each team from 6 down to 2 each team. So we ended up with 4 hybrid layouts. We looked at the best things of each layout and tried to kind of incorporate that into 2 layouts per team. So you'll see some like where, we looked at the vertical option, which meant taking the entire mezzanine and move it on the side of the building, and that way open up the entire pipe gallery, if you will, and then have all the electrical, the control room, the CO2 feeders on the side of the building. So everything will be at grade, everything will be at the same level. A lot of people felt that would provide easier accessibility, provide easier maintenance and reach for equipment. But that was one of 4. Then we took the 4 and basically scored them based on what we need as far as access, maintainability, safety, cost. We took all those factors into account. And our scoring system was from 1 to 5, 1 being good, 3 is better, 5 is excellent. -1, it takes away from the original design. -3 takes even more. -5 is probably not as good. So then we added the scores. I think what we've decided on after this, that to take basically the best of each one of those 4s and try to come up with just 2 hybrids. So we started out with 6 each group, 12 total, pulled them down to 4. Now we're working our way down to 2. So the first of the 2, basically, again, a lot of people like the idea of moving the mezzanine on the side, put the electrical control, CO2 feeders to the side. Everybody really agreed that we would like to see more access or better access to the sleeve valves and the hydro generators. So the idea of creating kind of a wide pathway inside the building to be able to pick up the generators or be able to move them out safely and easily was an attractive option to a lot of folks. We added a drain. Obviously there's a lot of water flowing through this facility. If we have a leak or a break in the line, it'll be nice to have at least a place for the water to go. A lot of us felt that we need flow control on these sleeve valves and hydro generators. Right now, our flow control happens downstream at the flock and set basins. And we felt that we would gain much better control by adding flow meters. Adding flow meters requires more of a pipe length, which meant instead of this header being against the building, it has to move back enough distance to allow for flow meters to go in. So each line, whether it's supplying a sleeve valve or a hydro generator, would move back roughly 30 feet so we can add a flow meter. That's still subject to evaluation depending on the type of the flow meter. Some flow meters require certain distance up and downstream of the flow meter. Some don't, so we can evaluate that. So that 30-foot distance is not set in stone yet. Depends on the flow meter we select. So let's see. Then we have the second one, Austin. So the second one basically maintains the mezzanine where it's at. It rearranges a few things. So you'll see the control room moves where it basically overlooks the pipe gallery. So we're looking down on the sleeve valves and the hydro generators. We've even allowed for an area once an operator enters the building, they have kind of a quiet area where they can at least put on their ear protection, their safety equipment if needed before they physically enter the building itself. Again, we like the idea of wider and easier access into the building with maybe some kind of a hoist system, a trolley in to pick up some of those valves or generators. We have equipment there that weighs up to 14,000 pounds, so moving them is something that we have to consider. Let's see. This one, the flow actually comes up goes down into the header, so the header on that one going out stays the same, but again, like the other option, the header on the front, we wanted to keep the idea of having flow meters, so that header would still move away from the building roughly 30 feet, again, depending on the type of flow meter we use. I think that's about it for this one. So the deliverables out of the 2P, one thing I think a lot of us considered is eliminating one of the sleeve valves. So we would have 2 hydropower generators with their supply lines, one line that supplies a sleeve valve. We eliminated the other one and left enough space for it if we need to add it in the future. But we had a meeting yesterday after we talked about it after the 2P event with the consultants. We ran it kind of internally with with O&M and engineering, and we decided to actually go ahead and keep the second sleeve valve. So we kept the space in the 2P, and now we've decided to actually just keep the sleeve valve and have 2 sleeve valves and 2 hydropower generators. Electric room removed from the mezzanine, added to the end of the building. As you saw, one of the hybrids, we take the entire mezzanine, move it to the side, and bring the whole thing to grade. So that was one of the deliverables. Flow meters on the hydros. So instead of having flow meters on all the pipes, we're not going to put flow meters on the sleeve valves. We're considering the flow meters just on the hydros. The monorail lift for tools and hydro components, that's critical, just due to the weight and size of those. The emergency drainage, that's at least the channel or the pipe, whatever the case might be, to allow the water in case we have a leak or a break to at least drain out of the building. Dock door, those are basically the entry into the building, wider doors to be able to actually get inside the building. Skylights to pull the sleeve valves, and possibly hatches to pull the hydro generators at some point down the road. And the shut-off valves on the header, that's where the flow meters would be. Those valves would be in the yard, not inside the building. So that saves the building space as well. So even as tight and good the design was, we felt that we came up with really still good improvements to consider and add on possibly to the design. So these are some of the insights. Things like don't overcomplicate it. And there are options. There is always options. And a lot of us felt that trade-offs are painful. You win some, but you have to give up some in return. You want to add a flow meter, but now you need a longer pipe run. Now you got to move the header back away from the building. Now you have to bury valves instead of putting them inside the building. So again, once you move one piece of the design or the puzzle, you almost have to rearrange a lot of other things. Hydro flow meters would help. Think long term. It's one of those things we have to be careful about. Well, we may not have to maintain it or tear it down for 10 years, but when those 10 years pass and now we have to deal with it, we really want to at least be mindful of what needs to happen in the future. Understanding maintenance is important. Like I said, it really was very helpful to have folks from Foothills, Joel in the room just to help us with their background on maintaining and operating a hydro. That was extremely valuable. Again, a lot of great insights. Arts and crafts are important. So we purposely avoided, some people prefer to work with a 3D model or some kind of a CAD drawing. The intent is with any lean event is you don't want it to be basically managed or driven by 2 or 3 people. You want everybody to participate. So that's the idea of using cutouts and stickies and notes. We want to make it simple. The idea is to create improvements, not to get wrapped around the CAD drawing or the 3D model itself. So a lot of great insights out of the project and or the event. Again, we took into account, again, the voice of the customer, the folks that are going to operate and maintain the system. So like I said, it was a great design to begin with, but I still think we've gained some efficiency and some improvement. So where we go from now is we are carrying 2 hybrid options, the last 2 drawings that I showed you, and we're going to send those to our designers and again look at them internally as well and decide on which one we follow or possibly even come up with a hybrid of those 2. But at least we boiled it down to 2 proposals on improvements. Questions? For the options, it is a difficult process, but that's really where having all these disciplines within the team helped. So when somebody says something that has to do with maybe architecture or mechanical design. We had folks that weighed in on things like that. Again, we've had people folks from Denver Water that knew quite a bit about hydropower generators and how to operate them, how to maintain them. Their input was extremely valuable on what works, what doesn't work. So having all these disciplines in the room really made kind of going through those options and boiling them down to something that's practical a lot easier. Yes, Andrea?
Maybe down in the weeds. Was it at all brought up, because the line is also goes there,
Yes.
and the distance from where line is in the chemical building to where it's dosed up in the Headler's building, trying to minimize that lane? Was that talked about at all, maybe moving the line up there?
It's something that we didn't talk about it in the 2P because there is actually a carbon dioxide feed, and those are the feed panels. The tanks are at the chemical building. There is a line feed point. The batching and slurry system is in the chemical building, so there is a travel distance. Also, the potassium permanganate. We didn't touch on that quite a bit. Our focus was more really on the layout and the efficiencies within this building. It's certainly something that we can address as we move closer to the 60%. Yes, cool.
Can you help go into more detail on the flow meters? So the designer originally designed it so that the flow control was passed.
Correct.
And this group decided that the flow control for the building or the plant needed
Closer. Yeah.
So
Yeah.
what drove
I think the concern was at the flock and sed where the flow meters are located, and that's where our flow measurement happens. There are 7 flow meters right now. You have flow meters on the water going into the flocks and seds, flow meters on the recycled water back to this building. There is flow meters on the injectors. So 3 flow meters on the inlets, 3 flow meters on the injector water, and 1 flow meter on the recycled water. A lot of us felt that we're doing a summation of 7 flow meters, and the percent accuracy of 7 flow meters may cause issues with the transition between a sleeve valve to the small hydro to the larger hydro to the larger hydro plus the sleeve valve. And that's where they felt if we have the flow measurement right there at the unit, it would be a lot easier to control and transition a lot smoother. So
So do you see the meters on the septic?
you do, because you need them at the basins, because you still need to control the flow going into each basin. And when you do the flow meter on the sleeve valves and hydros, it comes out into a header and then goes to the flocks and seds. So again, you combine them again, and you need to almost measure the flow all over again. And you also have the recycled water, which comes from the RFAQ basin. So that's a completely separate flow stream. And then you have the injection water, and that needs to be, again, metered so we can at least dose properly. So unfortunately, yeah, because we have a header going in and a header coming out, so even though you split the flow, you combine it back again. So, but certainly some that we can look at down the road as well. So, any other questions? Yeah, Patty.
How did the designers feel about all these changes here?
Actually, they enjoy it, because in a design meeting, especially leading up from a concept to 20% to 30%, I don't want to say you get a tunnel vision, but you're focused on certain design goals. Now you're putting designers and operators and maintenance folks and asset management folks in the same room. These are the things that we used to actually do after it's designed and built, and now we're doing it up front. So I really like the process, because this is where your chance to say, if we leave it untouched, this is what it's going to look like. And now let's walk through it and see, can you actually pick up this unit, put it on a truck, drive out? It's like, no, I can't, because I have no access. Like, okay, well, then let's look at an access. Do you have enough space to get to it? No, I don't, my control room is facing the electrical room. I need to get out to look at the hydro. I need to hear the hydro. How do you provide that? So we're putting all the people in the same room before we pass the 30% and say, does this work? And the answer is absolutely. Can we make it better? In most cases, we're finding out absolutely. So at least the ones that I work with within the 2P, they really like the process. They're excited about the process. Of course, when it goes back to the designers to incorporate this, yeah, you're fine tuning it, but that's fine. That's what they do. It's lessons learned for them too. So, any other questions?
I noticed it, as you were saying, part of your design was moving the electrical rooms to the battery rooms. But also one of Denver Water's concerns over the past few years has been like arc flash.
Yes.
Do any of the designs or address that better, or did you address it thinking this week? Or?
We do. We look into all that, but our focus in the 2P is more the layouts and efficiencies. The safety is one of the top priorities, but things like arc flash, lockout, tagout, emergency response, all that is incorporated in all those designs to begin with. If we can improve it, certainly we would do that, but it's always incorporated in the design from concept to construction. So yeah, arc flash comes up quite often, but it is accounted for in all of our designs of any electrical components. Any other questions? Like I said, this is the last 2P for at least the layout, and I'm sure there'll be more workshops to look at more things within NTP. It's a big project, but I really feel good about this process. I think everybody's excited about it. We're all coming together and looking for better ways to do things.
All right, thank you, Zach, for presenting. I'm sorry everyone else is in the engineering class. It's the last day for them, so I won't have that roadblock anymore. David always brings up to get involved and get out and get into an event. If you don't know how to get involved or get into an event, we offer a 3-day workshop every month that teaches you what is continuous improvement. You learn how to use the tools, and then out of that workshop, you end up with a project of your own that we come and support you on for at least 3 follow-ups, and if you need more follow-ups, we are there to help. But just reach out to us. We can get you signed up. Everyone that's been through it says it's been a great class, so I encourage you to get into that workshop. But other than that, have a great day.